Hi guys. So in coordination chemistry, we are doing IUPAC nomenclature of coordination compounds. We are discussing the nomenclature can be done easily by doing 4 steps. Step 1, I taught you how to find complex type. Is it cationic complex or anionic complex or neutral complex or binuclear complex? We are doing now step 2. What is step 2? Know the oxidation state of the central metal atom. Know the oxidation state of central metal atom. Now let me show you the example so you'll understand better. So know the oxidation state. Right. What I want. Can you please help me how to divide this complex? We know that whatever present in square bracket cannot be separated, right? So what I get? I get K will get plus charge and FeCN6 will be in square bracket. We can't separate that. We also know there are 4K plus, it should be 4K plus. Total is how much charge? Plus 4. So this must be what? Minus 4 charge. This must be minus 4 charge. Right? Yes. Now, so in the which type is complex? This is anionic complex. This is anionic complex. Now what I get anionic complex here? The metal atom is what? This is my metal atom. So metal atom is iron. So I want to find out the oxidation state of iron present in the complex. So this is my target. I want to find out oxidation state for this iron. So this is my X. So X plus, there are 6 ligands. So all are cyanide ligands is equal to what charge total? Minus 4. So X plus 6 into, if you remember the ligands charge properly, cyanide will be having minus 1 charge. Cyanide will have minus 1 charge. Therefore what? X is equal to what? This is minus 6 will become plus 6. So total X is equal to what you get? You get plus 2. So the oxidation state of iron in this complex is what? Plus 2. It's very important. Very, very important. You need to practice a lot. Now let's find out the second example, NiSCO4. So what I want to find out, what is my metal here? Which type of complex this is? This is neutral complex. You must know this. Yes. So how do I divide this? I can't divide it. I cannot divide because no cation, no anion. So I need to find out what central metal this is, Ni. So X plus okay, sorry, X plus 4 into, be careful, many of you will confuse the CO as cobalt. No, if at all I write capital C small o, that is cobalt. If at all I write capital C capital O, that is called as carbonyl. So metal can be here. So this is carbon monoxide, we call as carbonyl. So 4 into CO. 4 into CO is equal to what charge total? What is the total charge of this complex? Because it's non-ionic, the total will be equal to 0. And if you know the ligands table properly, CO will be having 0 charge. Total 4 into 0 will be 0. So X is equal to what? 0. So the oxidation state of nickel here is 0. Nickel here is 0. Similarly, let's find out the last one, example 3. How you divide? If you divide, you get what? Minus 1 for the bromide, plus 1 for the this complex. Which complex is this? Because my complex is caryon, so cationic complex. So I want to find out cobalt oxidation state. Remember, very often, or not very often, almost every time, cobalt will have +3 oxidation state in complexes. But still we'll calculate. Yes. So X plus how many ammonia are there? 5 ammonia. So 5 into we know ammonia is a neutral ligand, so charge will be 0. You must know from Ligands list, that is charge is 0. And Cl, we know that Cl, right? So Cl will have what charge? -1. How many Cls are there? 1. So -1 into 1 is equal to -1. Total should be equal to what? The total should be equal to +1. So +1 should be equal to +1. Yes. So if you calculate, see this? Sorry, a minute. So that should be actually Br2. So it should be Br2. So this will be +2 charge. This will be +2. So total will be X is equal to what? Now it will become +3. So cobalt will have +3 oxidation state here. Sorry. Cobalt will have +3 oxidation state. So this is how you find out oxidation state of any metal. Let's practice some examples. Yes. I'll pick randomly any one. So I'll try to do for this one, 16th one. If I divide it, what I get? I get Na plus charge. I get Na plus charge. How many Na are there? There are 2 Na, so 2 Na plus. So plus what I get? My SiF6 I'll get. What is the charge you get on this? This got +2 charge. This should be -2 charge. What is the complex type? So my complex is what? Anion. So this is what type? Anionic type complex. Anionic complex is, so therefore I should find out silicon oxidation state. So X is my silicon plus there are 6 fluorides. Each fluoride will have what charge? -1 charge. So is equal to what charge total? -2. So if you see there, X is equal to get what, sir? +4. So silicon will have what charge? +4 oxidation state. Okay. Silicon will have +4. Okay. So similarly, you can take some more example. You can practice. Okay. Yeah. Next, let's go for step 3. Know the ligand's charge, names, and density. Can you guys please understand here? I'm able to do oxidation state very easily because I know the charge of every ligand. For example, if at all you don't know charge of the ligand, it will be very difficult for you to find out oxidation state. Let's check back once. See, if at all I am able to do this calculation very easily, +4, because I know fluoride is -1 charge. If at all you don't know fluoride is -1 charge, you can't do any calculation. So therefore, knowing charge of the ligand is very, very important. Okay. Yes. Get back. So I'm just giving you once again. I know in the previous video I did it in important ligands. I'm just revising once again. So if at all I take a complex CONH3 5 times Cl square bracket outside Cl. So this is normal Cl, but this is ligand Cl. Please understand, this is ligand. So if at all I am talking about this, I should not call as chloride. I should call as chlorido. If I talk about outside one, I call as normal chloride, like sodium chloride. So this is normal chloride, but this is chlorido. I can't call as chloride. Be careful. We call as chlorido. So here chloride is sometimes, chlorido is sometimes. When is chlorido? Inside the square bracket. When is chloride? Outside the square bracket. Similarly, if at all we have Br minus in the square bracket, meaning ligand, we call as bromido. Charge is -1. It can give you only one pair of electron called as monodentate ligand. So similarly, H2O outside is called as water or called as hydrate, but inside the square bracket it is not called as hydrate or water. It's called as aqua. So ligand water is aqua. Similarly, SO4 minus 2 we call as sulfate outside the bracket, but if it's inside the bracket we call as sulfato. Remember, this is monodentate ligand, but charge is -2. Similarly, carbon monoxide we call outside the square bracket, but actually call as carbonyl inside the square bracket. This is neutral ligand, means zero charge. This also monodentate ligand. Same way, NO, there is no plus charge, minus charge, only NO. So nitrosyl we call as charge is 0. OH -1, hydroxido, charges is -1, monodentate. CN minus we call as cyanido, -1 charge. Ammonia is outside called as ammonia, but actually we should call as amine. If it's inside the square bracket, call as amine. So fluorido. So all these are monodentate ligands. Remember this, they can form only one bond with metal. But if you see this side, other side, check out this bidentate ligand. Bidentate ligand, there are so many, but I'm giving very common examples too. First one is En, we call as En. Full name is ethane 1,2 diamine. Remember, in formula we write En, but in the name we must write ethane 1,2 diamine. Similarly, we have one more bidentate ligand, that is ox, is the formula we use in the ligand formula, but name we should write as oxalato. Oxalato. And charge for the En is what? Very important, 0. Charge for the OX is -2, very important. So charge you must remember, otherwise it will go wrong. And also remember, OX is a bidentate ligand and En also a bidentate ligand. And last one, EDTA -4. EDTA -4. This is hexadentate ligand, meaning what? It can form 6 bonds with one metal atom. Very important. And charge is what? -4. And what is the name of this one? Ethylene diamine tetraacetato ligand. You don't see very often, but you can remember this. Okay? Yes. So these are the some important ligands. You must know all the ligands what I had given you. Okay? Yes. Now, step 4. Know the basic rules of nomenclature. It's not very complicated. Let's see here. I'll revise on screen. I'll tell you quickly. First one, when you name a complex, cation named first, then you'll name anion. For example, you may be seeing something called as NaCl. How do you name this? Is it sodium chloride or chloride sodium? Nobody call chloride sodium, right? We call as sodium chloride. Why? Because as per the IUPAC basic rule, cation come first. Cation name come first, then followed by anion name. So it's called as sodium and chloride. Okay, so cation name for come first, then will be anion name. That's a very important point. Next one. If the complex is cationic or neutral type, name will follow this pattern. Which is the pattern? Ligands must be arranged in alphabetical order, followed by I will write metal atom, followed by I'll write oxidation state of the metal in Roman numbers. See this? You have to calculate oxidation state properly, otherwise your name will go wrong. Be careful. And if the complex is anion, check out, almost same. Only one difference is metal will have extra word metal 8. For example, if at all you go for cationic complex, we call as zinc. But if you go for anionic complex, we call as zinc 8. We'll add 8. If at all, let's say cationic complex, aluminium. but anionic we call as aluminate. So you'll add 8 extra. So therefore be careful, when you have anionic complex we should add 8 for the metal. And one more thing is, if at all we have something like gold, silver, which has Latin name, in the anionic complex we should use Latin name only for anionic complex. For example, we have gold in the cationic complex, we'll write as gold itself. But if Au is present in anionic complex, we should write as aurate. We have iron. If iron is present in cationic complex, we use iron itself. But if iron present in anionic complex, we will write ferrate. Silver, we'll write silver as it is in the cationic, but anionic we write argentate, because argentum is the silver Latin name. Remember this. And one more thing is, I'm not elaborating more on this because I'm doing examples, then elaborate more on these steps. So the ligand name itself contains di, tri, etc. Then we should use bis or tris or tetrakis. Be careful, this is single S, KIS, not double S. Okay, tetrakis should be used. Meaning what? If at all I have 2H2O, we call as diaqua. Aqua does not have di-tri, so I use diaqua. But if at all I have 2En, check out this, I have En twice. What the En means? If you go and see properly, En means what? See this, ethane 1,2 diamine. Can you see the ligand name itself contains di? So if ligand has di, I can't use di or tri again. So we use the word bis instead of di. So we should call as bis ethane 1,2 diamine. Instead of calling as bi ethane diamine, we can't call as, we should call as bis ethane 1,2 diamine. So these are the basic rules of IUPAC nomenclature. So I'll solve one example quickly. Then we'll go for more examples in the next video. So example I'm doing is what? CO NH3 5 times Cl I'll take. So I'll take here as Cl2. Okay. So first I should know complex type. What complex is this? I should do it as CO NH3 5 times Cl. I must write like this, plus Cl minus. How many are there? Cl minus. There are 2 Cl minus, so there should be plus 2 charge. Okay. Should be plus 2 charge. Sorry. Yeah. So which complex type is this? Any guesses? This is complex which charge? Cation. So this is called as cationic complex. Step 1 is done. Next step. Find the oxidation state of the metal. If you do the calculation, X plus, sorry, X plus 5 into ammonia is how much? 0, we know that. Cl is minus 1, we know that, is equal to plus 2. So you get X is equal to plus 3. So oxidation state of cobalt is plus 3. Next one. We know ligands. What are the ligands? We have ammonia. What do you call ammonia ligand name? Ammonia means what? Ligand? We call as amine. So what do you call this ligand? Chloro or chlorido? It's called as chlorido. Okay. Yes, let's go for the name now. What are the pattern we have? Cation first, then anion. Now, if you see anion, it's very simple. I don't have to complicate so much, right? So Cl minus. What do you call Cl minus? It's outside, right? This is Cl minus outside. So we call as chloride. It called as chloride. So my anion is very simple. I'm done with anion. Only cation is complex for me. That's why I'm taking some time for complex cation. Right. So what is the pattern we have? If you remember the formula, see this cationic complex, ligands in the alphabetical order. Let's go for ligands. What are the ligands we have? Amine and chloride. Which one come first? Amine come first. So amine I should write first, then chloride. But how many amine are there? 5. So pentaamine. 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 Pentamine. How many chlorido? Only one. So chlorido. There should be no gap or no space between that. Should be one word actually. Be careful. So pentaamine chlorido. See the formula once. So ligands in the alphabetical order done. Now I have metal. What is the metal name? Cobalt. Yes, cobalt. Cobalt done. Then what I have? Format checkout once again. Yes. Metal. Then followed by oxidation state in the Roman number. So cobalt, open this small bracket parenthesis, write the Roman number as oxidation state is what? 3. So 1, 2, 3, Roman number 3 right in the bracket. Done. So read now. Pentaamine chlorido cobalt 3 chloride is the IUPAC name of this compound. I hope it is simple. Let's try for the next example. You'll be thorough with other examples. Thank you. Yeah.